All right, let's restart. So we are now in another place, and we were talking about the frustrated correlation.
Yeah,
right at that time. But did you want to follow it up, or shall we move on?
Let's we can move on to the next question.
Yeah. So the other thing that I also wanted to talk about, we talked about already quantum cognition and epsilon machine structures, quantum chaos, and the interpretation about quantum theory. So you're generally kind of neutral about a particular interpretation, or are you strongly supporting some interpretation like many word or?
I can't say that I strongly support any particular interpretation.
Oh.
I am sympathetic towards the many worlds because it does have a mathematical elegance of introducing minimal additional assumptions, but I'm not really a firm believer in any particular interpretation.
Or how about the Bohmian idea?
I don't think any of us like Bohmian. I mean, I don't know. Can you do qubit?
Cubism?
No. I don't know if you can deal with qubits with Bohmian mechanics all that easily, but probably you could, but it's painful. I don't actually like many world all that much because I don't think it gives you anything.
No, it's basically quantum mechanics. I would say many worlds is quantum mechanics with interpretation of how the observer would feel, maybe.
But you have to put that in by hand, it seems to me, right? Because I don't see how you get decoherence in many worlds.
No, you don't get decoherence.
So,
I mean, I would think that many worlds is really just a church of high Hilbert space, no? With the assumption that if someone is actually conscious, then they only see one branch of their reality, which is a assumption that I guess is put in by hand.
Exactly. So you have to put that in the consciousness by hand.
Yes.
Because all it gives you is mechanical world that has no agency.
Yes. So I guess
everything is predetermined.
Perhaps one should say is that I am sympathetic towards the unitarity of the universe.
Yeah, so I used to be, and I think that's less interesting than if there was a collapse model somewhere in there.
Certainly less interesting, but I just can't see how a collapse model is very consistent. At least
you can always ascribe so that's a good question. So suppose I go into a box and I put in a pure state, and then I really make sure that it's completely isolated, and I come back and I find it that has decohered, then I have a collapse model. So it is testable. Now, practically, it's not testable because you can't isolate a box to that degree.
And practically, if we did come back, we'd probably have the belief that it wasn't isolated, that it spontaneously collapsed. Like, it would be very hard to prove that the collapse was due to some intrinsic collapse and not because it interacted with some degree of freedom we're not aware of.
Completely agree. And this is the huge problem I've always had with the collapse model, that is not testable. It's almost not testable. Maybe it is, I don't know. But because you can always say that, well, it got entangled with something else in the universe. But what is nice about the collapse model, right? And I was not convinced about this until I think I thought a bit more about Penrose's thoughts on consciousness, and the idea is that if indeed there is a collapse happening in my head somewhere, it gives me access to randomness. If I can use that randomness to have genuine agency, not a fake agency, but a genuine agency, because I'm using that randomness, and that's actually a bigger solution than bigger solution to a bigger problem than what many world gives me, which just gives me a mechanical world, and it still leaves the agency and the consciousness part completely unresolved to a degree that is so uncomfortable that I rather go with the collapse model.
I have a question actually about this. So when you talked right now about this genuine agency, right?
Yeah.
You too also seem to be using this term agency and consciousness without defining it so far, and then it's so far okay. But I started also feel like at some stage I want to get you clarify what you mean by the agency and also its relation to consciousness.
That's a very good question. Perhaps the reason why we're just getting around this is because we don't have a very clear definition ourselves, but maybe I'm just speaking for myself. But for me, agents, when I talk about agents, I'm not thinking of them necessarily having independent agency. Agents to me is just a phrase for object, entity, whether conscious or not, that takes input stimuli and responds to it in some way. Now, one can argue that this is done in a super determinist matter where everything was already dictated by the laws of physics.
Like cell phone, agent.
Yeah, like cell phone could be agent.
I agree with that.
Yeah.
So no.
So like AI, when people talk about agent-based learning, the agent isn't really conscious.
Exactly.
It's based on a very fixed, well-defined set of updates.
And
and
what is
reaction
then
rules.
not non-agent thing then?
Like a rock that
Doesn't respond to
follows its physical laws of physics. Agents follow a bit more than laws of physics. They process information.
Of course, you can argue that information processing is.
I think it's a part of the laws of the physics, right? So to me, it's unclear what you mean.
So I guess
that's why I use the term genuine agency as opposed to phone having an apparent agency. I can talk to my phone and it'll talk back and it'll have a seemingly high-level conversation, but it's fake.
So for you, then genuine versus fake agency roughly corresponds to non-conscious versus conscious agent?
I'm not sure, right? But I think you are genuine agents. Those swans are genuine agents. But the phone is not a genuine agent.
So is it like a living versus non-living?
No, I wouldn't go that far, right?
Like
I'm not forbidding genuine agency from electromechanical objects.
So artificial intelligence can still have general.
So you have some kind of global or vague kind of notion of what it's like or what it should be like agent and what it shouldn't be like agent, but not really precise.
Should not be entirely predictable, right? I think that's exactly what Mila is saying.
Yeah. So I would say that when I say agents, I just mean something that it's an all-encompassing word for objects, organisms, or anything that responds to input stimuli in a certain adaptive manner, in the sense that they, so a rock isn't, really much of an agent because, it just does the same thing. It doesn't really care.
So the plants are agent.
Yes, in a way. You can look at the complexity of various agents by how complex the way they respond. So you can measure, these are objective measurements that you can measure from just their behavior. So
different time scales.
Yeah.
The plants will have agency at a long
Then
time scale.
how about as a lake as a whole? That's also agent because they are also reacting the input of the weather and then also have some kind of a temporal dynamics and things like that.
Yes, in that sense, I think you can say that almost everything is an agent to a certain degrees of complexity in terms of, say, a thermostat is an agent, but it's a pretty simple agent that responds.
So it's a continuous degree.
Yeah. So, and you can measure this by, well, how much structure it has to have in its memory. So this is all very objective. The more esoteric thing is, I think, the agency, or what you would like to call consciousness, or so this intrinsic.
So agency and the consciousness in your mind, it's the same thing.
I don't know how to define agency directly. I use the word agents, as I just mentioned, to mean anything that adapts to the environments. Consciousness, perhaps, is the one that is different. And consciousness is much harder to quantify, right? Or define. It's almost impossible to define it from a outside perspective, right? As physicists, we like to define things objectively through outside measurable quantities. So with agents, I can measure the input and output reactions. I can give a bound to its internal structure. I can say it has to at least, process this much information. These are firm, definitive mathematical statements. But then when we talk about consciousness and ask, did the agent consciously make that choice? Or was that choice dictated by him from a super deterministic manner? Or did the agent make that choice through intrinsic randomness? Those are three different options that are quite difficult to discern. And in particular, the difference between agent's intentional action and randomness is something that I think is very difficult to quantify or even distinguish. Because say if you had a completely random qubit that collapsed either to the 0 state or 1 state, would that give it consciousness or would that give it agency? Because we can't predict its answer. I think many people would say that it is not conscious, it's simply random. Or if we had a true dice that that can flip randomly from 0 to 1 to 6, does that give the dice automatically agency or consciousness? It's even if we had a random dice that's not dictated by what happens in the environment, I'm not sure if everyone would agree that that dice is actually conscious. So
yeah.
so you feel like that agency,
unless you have panpsychism, right? And then that's taking it too far.
that I feel is taking.
And that's
it too
why
far.
I think panpsychism is like the extreme opposite of many world interpretation.
Yes.
Yeah, so that's that the reason why I wanted to go into the deep of this definition of agency and agent and consciousness is also related to your statement about panpsychism. But one step back, to me, the definition of consciousness is actually not that difficult in the way that if you just accept this what you are experiencing subjectively, any kind of sound or vision or emotion or thoughts that you're experiencing directly, that's the consciousness. And if the rock has that, if we can become a rock and if we have the same kind of thing, then they are experiencing.
No, I agree with you. The question is how do we test
this? So
this?
we don't have that right now, right? And we also don't know how it feels like to become a bird or become a plant. But for the case of the animals or like babies and monkeys and so on, at least the closer cousin of our ancestors,
we tend to believe they're conscious.
Most likely, because if you really believe in the brains are responsible for consciousness, that's similarly now, right? To not it's very difficult to think that there is a really sharp boundary that humans with the language are the only ones that are having experience like us.
Yes.
So it's gonna be different. Like the color wise, they have a different kind of sensitivity and a different kind of a memory structure. Like they don't have a strong working memory and the syntactic structure and so on. So they are feeling differently, but they probably have something, right?
Yes.
And we go into non-conscious state under anesthesia or deep sleep. So that's also somewhat one way to clarify what the consciousness feels like. And then coming back to this agent or agency and the consciousness kind of stuff, that it seems like both of you as a physicist tend to take this choice or behavior or output as a very canonical thing to measure or hint to get that
No,
agency. No,
I disagree. No,
Okay.
I'm talking about so if you believe in many world interpretation of quantum mechanics and if you think that everything is quantum, it leaves you with no room for consciousness and agency. Everything is predetermined. If you go back to a quantum version of Descartes' mechanical world, there is no choice. It's just all going to happen. There is no, I mean, this conversation is predetermined.
yeah,
There's
that's
nothing you-
ridiculous to me. Yeah.
Exactly. So in order for you to have that,
So I would say that many words would more like to say every conversation is predetermined in the sense that
yeah, but they're all happening. So
they're all happening. But
this one is just
yeah,
we're privy to only one of
but
them.
you could argue that as consciousness you experience
But it
only
doesn't-
one trajectory.
Right, but I mean, this is where I have a problem with it because that requires some sort of decoherence, right? That's a half-baked. theory that
Yes.
Somehow I see only a particular classical world, but why is that? Why? I mean, where are the other ones? Why can't I bring them back?
Yes.
So I
Well,
think it's
one would
slightly
argue-
half-baked.
I guess if one could reverse interaction, then one could test this, right? You some of the recent Wigner's friend proposals and the forgetfulness proposals, where in principle you can unitarily reverse a measurement elicited on a piece of paper, and if that can in principle be done, then one may argue that the person is everything was unitary during the measurement, at least. So if you could actually have a conscious person measure a cat, which is just a control knot operation, and then undo that control knot operation, then one could be.
But it still leaves the essence of agency untouched, right? It just says that it exists. It posits that it exists, and it's sort of a disconnect from all the other worlds that you feel it in.
Yes, that is true.
But what I like about the Penrose version, at least my interpretation of it, my maybe poor interpretation of it, is that if you have an intrinsic departure from quantum mechanics, there is some decoherence happening.
Then yes, then in principle you can get something.
Then I can use that.
Yes.
I can use that randomness to create agency.
So maybe just to combine with what I was going to also ask, which is this locked-in syndrome, or some person who just cannot make any kind of overt behaviors output at all right? But they are conscious, and then sometimes they recover and they can report what they were feeling and so on. So that kind of thing, person is very difficult to consider according to your framework, like who doesn't make any choice or whatever. But according to the Penrose kind of idea of intrinsic collapse, because something is happening in the brain.
I probably should clarify. So if you call my framework, the measurements are obviously in general incomplete. So they can only give a bound. So when you measure it, you can say at least they must have the structure, but it gives a lower bound. It doesn't give an upper bound.
But actually, we did think about this, and I'm glad you brought this up, because when we were talking about this a few years ago, this was one of these examples where somebody in locked-in syndrome, they actually have no agency, but they're conscious.
Right.
And I always like to bring up this book, Johnny Got His Gun. Where he has minimal agency.
Right.
But a full-blown conscious experience that is detailed in this book that is undeniable.
Right.
And so I think that's the difference, right? Between agency and consciousness.
Yeah.
But one could also argue that even with people in locked-in syndrome, they still have the potential for agency, provided they were given the tools to do so. So we can verify people with locked-in syndrome through sort of MRI scans and stuff. And one can envision that in future there will be technologies that allow them to actually utilize their consciousness for agency.
Yeah.
So they still have the potential for agency in there. That's just unrealized.
If you start to talk about potential for something, then anything like rock can be potentially, as an agent, right?
When we talk about quantum phenomena, we can't make most of the measurements that we envisage in our theories.
Yes.
They're impossible.
Yeah, but
impossible because of the poor technology we have. But they're not impossible. They're not forbidden.
Yeah, just like with a person locked in syndrome, they're unable to affect the world through the lack of current technological means. But
the same goes with this iPhone as well, right? If you attach this to something that is more like a biological. I mean, we usually think about extending our brain with the iPhone. But from an iPhone's point of view, if they get connected with some kind of biological agent, then they are now potentially can be considered as a locked in. But can be
our bias is your lights on. I don't think you want that, considering you want to save battery.
Yeah, that's it's fine.
No. Turn your phone around.
Oh, the torch.
Right.
I mean, maybe that's your phone signaling that it is.
it
is conscious.
Make it clear.
I'm locked in.
Yeah.
So, I think that phone has agency but has no consciousness. I mean, I could be wrong. I'm open to that, but I genuinely think that. I just don't think it's all that smart.
So you think this has an agency because it has some kind of a capacity to process the input and make some kind of output
in a highly complex way that you and I can't do. It can calculate square root of 2 to a great degree, and it does it when you ask it to.
So in your view, agency and the consciousness can go together in general, maybe potentially through evolution, but currently, especially with the technology, they can diverge quite a bit. Like on one hand, it's through the medical kind of advancement, and on another one, direction, engineering advancement. We have an agent which is not conscious, or we have conscious but non, agent kind of existence.
If we were having this conversation 200 years ago, we would definitely say that consciousness requires, agency implies consciousness, right? But now it's no longer the case. We can have these two things be distinct.
In the end, yeah, you have these philosophical zombies, right? The idea that you can build a machine that, you can build, say, mechanical neurons and replace a living neuron with a mechanical neuron. Eventually, perhaps replace the entire brain with the resulting person who maybe still act exactly the same, be conscious or not.
And that brings in that third layer, intelligence. You don't need intelligence to have agency or have consciousness or vice versa. They really can be all distinct. You can have intelligence. Okay, I don't know. Can you have intelligence without agency? Maybe you could.
Yeah, but before going to the issue of intelligence, about that philosophical zombie stuff, if you really carefully examine the assumptions about zombies, what they are saying is that the replica of you, which is exact replica down to our atoms, molecules, and everything, and still are not conscious of anything at all. It's just, to me, ridiculous thing to even consider.
Well, that's an extreme philosophical example, I suppose.
But their argument is that the mere fact that we can actually conceive of this kind of entity is enough for them to think about this kind of possibility. But to me, this kind of logical possibility type argument, which is just impossible in nature.
Yes, certainly. Not in the foreseeable future, but if we build a very sophisticated AI system that can pass every single Turing test we throw at it.
Yeah, but the substrate is already quite different, right?
Yes, the substrate is very different, but would we argue that thing is definitively not conscious if it passes all sorts of Turing tests?
Yeah, so we don't know, but what I'm saying is that from just a perspective of the function, input output function or behavior outside of behavior, we can't determine the internal experience,
no,
at least in the way that we
completely
understand,
agree with you.
which is a bit contradictory to what I said about the Yoneda lemma, right? Yoneda lemma, according to that, if we fix or completely characterize the outside relations, then we can also know the internal structure of the things.
Well, knowing the complete internal structure of something still doesn't necessarily mean whether we know it's conscious or not, right? We can presume, certainly with humans we can't do it, but we imagine in the foreseeable future we might be able to simulate a virus on a quantum computer from first principles. First of all, we have to agree whether we think a virus is conscious or not, and I suppose that's highly debatable. But suppose we believe the virus, being a living organism, has some degree of consciousness. Then
we have to debate whether viruses are alive first.
Yes, bacteria. Okay, maybe we go one bit further and go to bacteria. Everyone at least agrees they're alive. But then would we say that these things are conscious because, or would simulations of them be conscious because because we can simulate them from first principles?
Yeah, so for that, we need to think about this, grade or scale, and also, many different kind of complexity or structure kind of arguments. So definitely we are not saying that, viruses, even if they are conscious, they wouldn't have similar kind of memory or sensory experience of different senses and so on, right? At all.
Yes.
Maybe it could have some kind of state of the wakefulness versus non-wakefulness or something, but even that I don't think they would have, because of the structure and their state is not like same like neuron neuron of the flies, for example, very small one like we published, they, even if they are really small like this size, the number of the neurons are surprisingly like 0.1 million.
Yeah,
and each of them can be on or off state.
Yes.
So if
It's
you
a
think
much
about
more
that, it's
structured.
really structured and it's
Yeah.
much more complex, right?
For sure, for sure.
So that kind of entity, I can imagine at least to have some level of having experience state like wakefulness versus completely gone like in
Yeah.
deep sleep, and also differentiated kind of quality, like they may feel like excitement or not, or smelling or not, a different type of a smell or different
So I
types of
guess for
vision.
you,
and
the
so on.
consciousness is the ability for personal experience.
Yes,
Yeah.
yes, and also differentiability as well, right? That's
Mm.
definitely important aspect of it.
Yeah, I guess the issue, is that personal experience is very hard to measure.
Yeah.
And as I was saying, there's also these things about is like, can we differentiate, or is it even meaningful to differentiate something that is intrinsically random and unpredictable, and something that has a conscious intention or agency that makes an actual choice?
But
So
maybe one step before, right? When you say difficult, I always have this kind of conversation or program, right? Like to decide whether I'm conscious or not, you can measure something like converse or something
no,
like that.
I can't. There's nothing I can measure to decide whether
Okay,
I'm
then-
conscious.
But that's I would say like a really extreme view, or it would be similar to
Probably not that extreme among physicists. No, I think this would be the common view of physicists.
So yeah, I mean, we can certainly come to an agreement by putting a threshold to say what is conscious, but the problem is that then there will be a machine that will fail, that will pass all those tests, and you could call that the hyper Turing test, and that will be
okay. Let's put aside the machine stuff for now.
Yeah.
But
well, how do we know you're not a machine, right? That's the
okay, you can examine my molecular kind of construction and many things, totally fine, but just as a sort of the common sense definition of the consciousness as defined as an wakefulness versus unawakefulness, that level of the definition, or locked in people who are actually thinking and experiencing something like that versus not.
For everyday practical purposes, yeah, you're right. I mean, we can we genuinely think that you're not sleepwalking right now,
right?
And are aware of aware of this conversation, and will be so tomorrow and next year when we and we have, since we have recorded evidence of it, we can actually test that. But I think the question that Mila is trying to answer is a more sort of a philosophically foundational one.
So that's the one that I wanted to come, right? So we talked a little bit about the Kant's, criticism on impossibility to study psychology or consciousness because of the property of consciousness or psychological thing which is influenced by the measurement or observation. That's one aspect of his argument. The another aspect is that according to him or many different philosophers and scientists, introspection, which is the only way to quantify or measure internal consciousness, is never precise enough, noisy. But when I see redness here, I see red and I can report the redness, in some way. There is some kind of noise. But the presence of the noise doesn't preclude for us to do science about that, right? And also you don't say that, even if the measurement is not 100% precise, it's not like a unreliable measurement. You wouldn't say that you can't measure things.
Yeah.
It is unreliable, less precise, I agree. But it's not the same thing as, impossible to measure.
With consciousness, it's the question is, I guess, what are we perceive consciousness to be? I mean, philosophically, as Kavan mentioned, whatever discriminator we have, in principle, it's possible to build a machine that passes the discriminator. So in that sense, unless we're willing to say that some machines pass what our definition of consciousness is, then it would be impossible to have a distinguisher of consciousness. But if we're happy to say that, okay, a machine sufficiently sophisticated is going to be conscious, then yes, we can probably have some measure of consciousness. But the measure would be kind of like one of maybe structure, adaptability, but not necessarily of the ability to possess qualia, since that's something that we can't really measure.
But now isn't this precisely the distinction between the hard and the easy problem of consciousness?
Yes.
Yeah.
That we can't actually solve the. I mean, the hard problem is too hard in a way. That's the thing that Miller's trying to address, and you're addressing the easy problem of consciousness, which is not easy, but isn't that the distinction that Dave Chalmers would make?
So this hard problem has many aspects on it. So and it's often confused, but there are many versions of it, right? One version is built on this philosophical zombie argument,
right?
Where as long as we can conceive an entity that is exact copy of you, down to atom by atom or molecule to molecule, still they can they still don't possess the same kind of internal experience. Then we have no way to scientifically link, in a sense, the internal experience with the physical things. But that whole argument is based on this assumption that you can have such an entity, which I think is just ridiculous, or at least there is no evidence to believe such a thing is actually possible for me. So the reason is that every time when you damage the brain systematically, you can lose some aspect of the brain systematically. So there is a link between the internal experience to the physical existence. And the physical existence, as we know as a neuroscientist, is that particular part of the brain is related to other brain region or other neurons. So I think in that sense, I really feel like Carlo Rovelli's idea quite attractive and close to my thinking, which is that there's no sort of special types of the relations in the world. Every property is basically appearing to another entity through the interaction or relations. And what this brain is about is all about one neuron's existence looked at from other neurons, right? So there's a huge web of the causal relations or network of mutual information inside the brain. And that particular structure of the relationship are also related to phenomena or qualia. So, and this is definitely not a conventional kind of thing, but this physical relation to relation of the kind of phenomenal may not be the same thing, but I think linking these two types of phenomena is fine.
Agree that it would be interesting to link these phenomena, and there's value in that, and that perhaps that once you have networks that are sufficiently complex, they will develop their own consciousness. I mean, one other perspective is that once you get these networks sufficiently complex, then that network inside will manifest some sort of internal experience.
I'm not sure I agree with that.
I'm not sure I agree with that either, but that's just one view, right?
We have the internet, we have supercomputers, I mean, that are capable of doing things that humans can never do. Never mind a little mouse.
That is true.
So I mean,
well,
now you could argue that it's not just
the computing.
It's not just a single number that attributes that we can
but we
use.
still We still, as far as I know, don't have the computational power to completely simulate our brain, right?
Shall we
Do we?
speak to here?
Yeah, sure.
In what sense?
All the information processing in our brain down to every single neuron, every single pulse, and every single neural spike. We don't have. I mean, there was a human brain project a little while ago.
It's still going.
Yeah. So.
No, I mean, I don't understand what that means. So how many neurons does a computer have? I mean, a human brain have? Or let's say
86 billion.
86 billion. So how many? Let's just say I model each neuron
But,
with
you
a
know,
transistor.
Yeah, so in terms of number
So why
and
can't
the
I do-
complexity, one thing to also notice is that the human brain, right, cerebral cortex, that has roughly only 20% or less number in terms of both number of the connections and number of the neurons compared to cerebellum, back of the brain.
Right.
And the back of the brain cerebellum, if you lose it, you don't lose much of the consciousness. And also, there are some certain people who are born without it, but completely functional, completely conscious. And we can sometimes, remove this entire cerebellum. But
Do you know what its function is, the cerebellum?
Basically the precise control of the movements.
Right,
So
right.
language and the movement and the
Right,
learning of this.
So a lot
actually
of
requires
internal
huge-
processing, right?
Yeah.
But not necessarily on the conscious decision making.
Right.
It's all done
And
unconsciously.
not to mention all of the other bodily functions that are completely unnecessary for a conscious experience,
Yes, you don't want to consciously know you're breathing all the time.
or
Yeah.
your heart is beating. You don't want
Yeah.
to stop that. I mean, I could certainly say that, I don't know, what's the largest number of transistors I can have on a chip? It's probably in trillions, right? I don't
Yeah,
know.
it's much more than
So what, in a way, in the crudest way, we've already surpassed that limit.
Yes, so I imagine that they also need to be processing together in a certain way.
Yeah. So that's a practical question, I think.
Yeah.
Like, I don't think we need to stop. Like,
Because
we just can't measure consciousness or not.
the
Because,
human
we
brain
know.
still have a lot of structures that we don't really understand, right?
Exactly.
But it's true that we can surpass a human in things like playing Go and whatever. But if you look at the amount of power that we use to do that, it is orders of magnitude higher than what the human brain uses. So
Oh, that's okay. I mean, it doesn't have to be perfect right now.
Yeah.
All I need is
Yes.
need something to think it. I mean,
yeah, and it doesn't, of course, do any of the other things that the human brain must do. At the
so
same
I mean,
time.
it can't be just a number game, right? It has to have more
No,
architecture than that.
yeah, absolutely. I
Because
completely
otherwise-
agree.
That's a structure.
Yeah, that's a structure.
That's the structure. I mean,
Yeah.
but that's a different structure than the external structure, right? The internal structure is far more difficult to understand and
Yeah.
mimic and manipulate. Right? Otherwise, you would think that a beach would be conscious with all the sand grains that are
I know, absolutely. That the interactions, of course, has to be sufficiently complex.
That's right. Because after all,
Mm.
silicon chips are made of sand.
Yes.
So you would think that if,
The beach will be conscious. Yes.
yeah.
You have a very good point. And yeah, so yeah, I agree that absolutely structure is of utmost importance. But you could envision that once you have a sufficiently complex structure with sufficiently many pieces of information, that perhaps there is some intrinsic consciousness that is born. I'm not saying that I agree with this. I'm just saying that this is a view that one can take as a perspective. That
Yeah.
I mean,
and that's
that
difficult
kind
to
of thing
falsify.
is at least much more promising to explain why do we lose certain aspect of experience when you damage certain aspect of the brain, right?
Yes.
If you just remain in this kind of view that sufficiently complex thing just automatically becomes conscious, or input output is the necessary or something like that, then you can't just explain anything about why this particular part of the brain, if we lose the color. That doesn't make sense at all. And the way we also lose color, when we damage this brain, is not like we lose only green or only red. That's consistent with what I said in the beginning, where when we lose color, entire structure of the color is lost as well.
Right. So we just don't experience it.
We don't experience the any of this ring structure or similarity of the color. It just becomes like gray, intensity kind of thing. Shall we stop the recording?
Suspected spam.
Or okay.
That's suspected spam.
So I think getting to that kind of
Either that or your phone is trying to tell you something.
Yes.
Now his phone is something. I think maybe
Yes,
there's
they could be conscious. We never know, right?
Well, we're ignoring.
Yeah.
I mean, perhaps cerebellum has a separate disconnected consciousness that just manages our bodies.
Yeah.
Never talks to anything else. We can't rule that out. I mean, I don't necessarily believe that, but I mean, it's not entirely outside the realm of possibility that there's a consciousness there, half consciousness there, droning on about makes his heart beat.
But that's potentially true. But what we know from the neuroscience is that the way things are connected in cerebellum is very different.
Yes.
Right. It's mostly like a feed forward, and it's mostly that they many small modules are optimally making a process of the timing. So each of the small modules are not interacting with each other.
Right. So it's a very different structure than your conscious part, where there's a lot of interaction. That makes sense.
Right.
Yeah.
So
then the structure is a lot simpler, I guess. It's a much
simpler,
much more linear feed forward structure. Which,
What's the? I think we've discussed this at some point. Something I still don't have a clear answer on. Like, what's the connective nature of the brain, part of the brain that we think has consciousness residing in it? I mean, is it sparsely connected or is it highly connected?
It is sparsely connected, I would say. So the number of the neurons in the brain is probably 10 to the 11, right? And then only 20% of that is cerebral cortex. But each of the neuron itself is connected to roughly 1,000 to 100,000 other neurons.
That's from a physics perspective, that's highly connected.
Yes, because we think about Isaac's bubbles.
So this silica stuff is not that connected.
No.
And that could be the one big difference between you can have similar neurotransistors, we just haven't connected them that well. But it's very hard to do, by the way, physically.
Right. Also, in the case of the areas that I suspect to be highly related to consciousness or visual consciousness in particular, like this, kind of a vivid sensation, they tend to be connected to neighbor, similar neurons. Right. And then far away neurons are connected, but less so. So it kind of, paints some kind of the grid of connectivity. Whereas the thinking part or, sparsely connected part of the brain is more like a random connection.
Right.
But, it can modify the connectivity strengths so that, it can do cognitive process much more effectively. That's sort of the, still working hypothesis, but there is more and more.
So once if the cerebellum is removed for someone, they definitely become unconscious, right? They can't do anything.
Cerebellum?
Yeah, I mean not the cerebellum.
Cerebral cortex.
Yes, they use the cerebral cortex.
Yeah, so they can recover.
Right.
But if it's a frontal part of the brain, then they actually survive, and they just become quite unreliable, and in a sense, it becomes like a psychotic or very unreliable liar, and also emotionally unstable person. But still, they are conscious.
Right.
They hear, they see, they smell, and so on.
Right.
But the back of the brain, you lose vision and you lose sensation.
I read about this thing about this chicken who survived being headless for a while.
Chicken.
Yeah, there was a chicken that was
circus chicken, I think.
Yeah. So they tried to chop his head off, as you do with most chickens when you want to cook them, but they didn't make a clean cut, and a little bit of its brainstem was still there, and then the chicken was able to survive and still, I guess, react to the environment.
Yeah,
To classify as being conscious.
No. I mean, we don't know, first of all, but from our knowledge, it's probably unlikely that they experience anything like vision or smell or something. Maybe there is something to wake up or not and so on. I mean, vegetative state sometimes the result something like that. Like there is a functioning part of the brain that controls the breathing and so on.
Right.
But content-wise, it's
Right.
there. But we don't know about that. So input-output relations are not enough. That's my point.
That I agree with. I think
agree as
we
well.
all agree with that. But they put a bound on it.
Yes.
Um,
And it's a lower bound, so it doesn't.
Yeah.
Someone could be completely locked in unconscious
Right.
and have zero ability to affect the output. So
Yeah.
you can have something with input-output relations, say zero functionality or
Yeah.
zero adaptivity, but they're still conscious, just unable to leverage that consciousness for agency.
Right.
But if you see something display complex adaptive behavior, it means that there's some minimal structure in whatever they're doing, beyond simple Markovian dynamics, which is basically what we can measure with these things. So something that is very simple is something that is completely Markovian, right? You kick it this way, it responds that way. It doesn't matter what time you do it. It has no memory of what happened in the past. A very simple model, we call it a memoryless channel. Basically, it has a well-defined function between output and input, but no memory. And then as your agents become more complex, they can remember stuff about how you did in the past and be able to integrate that into its chosen responses in the future. And once you want to do anything that requires planning or coherent strategy, then you need these things. And that puts a higher bound on the structure of the controlling unit for that agent. Now, one can still say that this controlling agent can be much more complex. It just uses a small amount of that to do this response. One can also say that this controlling agent is not actually conscious because it's just a computer or whatever. So that we can't rule out. But it just gives you some notion of the minimal structure needed to see these things. And this is what we can objectively measure. Anything beyond that, it becomes much more difficult to objectively measure, I guess, because we don't know, for example, how to distinguish pure randomness from intention. So often, at least in computer science, the notion of agency isn't just unpredictability, but it's also the ability to use that to do some goal. So in the sense that a completely random dice, is not an agent, because if it's a die, it just rolls randomly 1 to 6 for no reason. To leverage that, there's that randomness, but also, the agent needs to be wanting to do something. That's the notion of intention, and I suppose that one probably wants that in consciousness as well. Now that is much harder to objectively measure because it's very difficult to distinguish. Did the person choose? Did the dice choose to output 1, or whether it just randomly outputted 1? Sort of, is a machine armed with a completely random number, perfect random number generator conscious?
Yeah, it's difficult, but I don't think we need to make that kind of a conclusion that too extreme conclusion to that's very difficult to reconcile with what we know neuroscientifically. But by the way, Kavan, when we were collaborating on the epsilon machine thing, we had some kind of a way to analyze the structure from sort of the series of the outputs or response of the system against sort of the fictitious perturbation from outside. or just looking at sort of the series of the outputs, and then compare that with the statistics from some kind of random sequence or something like that, right? Are you working on this type of the physical measure or analysis to quantify the degree of the or characterize the property of the structure, internal structure of the things?
No, I mean, so the inferred internal structure then is just too messy, and it's a graph, right? And so the computer gives you a graph, but it doesn't necessarily give you the same graph, right? So if you take the same fly, two different neurons very close to each other, or two different parts of the brain, and you construct a graph based on the epsilon machine statistics, or the time series statistics, you construct an epsilon machine and the graph corresponds to the epsilon machine, then two graphs may look completely different, but they might be identical. Or they might even be approximately identical. That's even a harder problem.
And the graph isomorphism.
It's the graph isomorphism. Now, it turns out that it is proven now that graph isomorphism is an NP. Hard. It belongs to P. But
graph isomorphism belongs to P.
I believe so. I think isn't that the result by Babai that it's computable on a Turing machine in polynomial time. No one knows what the polynomial is, but there's this recent computer science result.
Yeah, I think I vaguely saw that in the archive. I wasn't sure if that was confirmed now.
I think so. I think that's
so they have verified the proof.
I don't know, but I recently heard someone. I think I recently heard Scott Aronson talk about how it's not as bad of a problem as one thought 5 years ago or 10 years ago, whatever it was. But we have no idea. It's still a bad problem. So it makes it practically kind of a nightmare to work with, unless you work with very small things, and then it's maybe not as interesting. So yeah, I think we sort of dropped that.
I mean, one can still give the quantifier of the structure, but you're right. The causal maps themselves is difficult to map one to another.
You can't learn anything from them, not without having a model in mind.
Yeah, so I can imagine that would be the case, and so here comes my interest of category theory.
Yeah.
So I think it's a homotopy type theory that and also univariant.
What is homotopy?
It's like when there is a path from this way to that way, and then if you can map onto something else, and then you can preserve this structure, connected structure and relationship into another one, then you consider it as an equivalent.
So it sounds like a graph isomorphism, yeah, but it's a map that
continuous
preserves graph isomorphism continuously, something like that. Okay.
Yeah.
I think I have some intuition for it.
Something like that would probably be able to find the equivalence class of exact graph and different kind of a graph in relation to something else.
Yeah.
Right. And our brains are all different, definitely. But presumably we are seeing the world in more or less similar way.
Mm.
And this similar way, where does it come from? Maybe coming from this type of isomorphic structure of the causal relationship. And if that's the case, then it's going to be super hard to prove it. But at least I think there's a pathway to study. Like one particular type of the structure corresponds to this type of the Qualia structure and so on. And that's my hope.
Yeah, I mean, one would think these. I mean, if you look at the minimal agents, you would say that these are the minimal amount of brain structure the agent needs to have. Okay, great. To be able to distinguish, to be able to respond differently depending on different input stimuli. So you sense that it needs to have at least that many mental states and that many ways of sort of observing reality. So one could argue that if an agent displays certain behavior, then it places a qualification on, well, at least certain existence of certain differentiated qualia states that it wants to respond to. But as Kavan mentions that labeling these things would be tricky because there are many different possible rearrangements.
Right.
But so that would be computationally very intensive. But in principle, there should be a link like that.
So some my colleague is trying to deal with this type of a thing as a sort of a problem of translation, right? So one language and another language has a completely different kind of components and elements, but the relations between the elements are kind of the preserved thing. So if one can translate from one language to another and then coming back to the original language in terms of semantics and sentence, then to do that you need to find sort of the structural correspondence, or we need to understand the structural invariance or something like that. And there you don't need to find the exact sort of correspondence, identify element or graph exactly. Something like this may be used for structural analysis of the complex entity.
Yeah, I think you're right. Having to map the whole structure seems too hard. You just need to map parts of it. You don't need. I mean, it's like here we are, right? We want to go back to Flinders Station. I don't need to memorize the whole map. I just need to know the map as we go.
Maybe it's a good time to stop and take a break.
I think so.
I think so. I unfortunately have a few administrative duties I have to attend.